Wow. Repeating crossbows are getting smaller and smaller and more powerful. But all this new technology comes with a price. So I present to you the biggest disadvantage of archery in particular, the strings, because often just after a few dozen shots in a repeating crossbow, your string looks like this and needs replacement. That is really frustrating. People that are new to archery and crossbows and repeating crossbows in particular know about this issue, and they have learned to deal with this. So constant waxing of the string like every 10-15 shots, and then of course renewing the middle serving to save a string like this. This definitely is something that they've gotten used to, but newcomers hate it, and I have to say I also see this as a very big issue because you want a reliable weapon. What is all this, fast shooting, fast repeating, precision shooting thing worth if it's not reliable? Now, crossbows have come a long way since the first medieval versions or even ancient Greek versions. Now we have, as you just saw, reverse bow compound technology, and we have, of course, magazines, and I had my part in this. So they are now completely different weapons. But the reliability issue has gotten worse and worse because a repeating crossbow, you just shoot it more often, and then you run into defective strings far earlier than if you shoot like complicated winch cock devices. Funny is that crossbow strings have been designed the same way forever. Yes, the materials are now a little different, but basically we are talking a long strand of a thin string, and then it's usually like wrapped around in a loop, and then it's stabilized by serving it. This means you actually put some additional string, different type usually, this way around it to stabilize it. And you do the same for the eyes, for the eyelets here, so that they have some kind of resistance against wear. And this used to be done with like natural fibers and so on, and now it's a more like artificial and high-tech fibers, but still the problem remains. As soon as the serving gives up, the string is shot. And it's not cheap. I mean, a thing like this costs 25 euros. And it typically lasts maybe 100, 150 shots. But what if I found a way how to make a string that is much better than one of the commercially sold ones? Holds longer, is faster, is lighter, and you can make it for less than €1 at home with almost no tools. What if? Well, let me take you on a ride. It all started when my crossbow, my homemade winchcock crossbow failed because the string tore, and that was actually a paracord string, and it wasn't solid enough. People suggested use Dyneema rope. It's so much more sturdy at the same thickness. So I got some. So this is like a short piece of the Dyneema string that I'm using. In this case, the 3mm type. Now, what is Dyneema? Well, it's an artificial fiber, of course, and Dyneema strings are used in crossbow technology for strings, but then they use it in the same fashion. Just the same thing, just with Dyneema, except than anything else. But this actually is different, because see, this Dyneema is actually, if you press on it, you can really see it. I hope you can see it. You can see that it's made up from 12 different strands that are interwoven, and they're also specifically coated. Since these are used in like sailing and for heavy winches and so on, it's like 16 times stronger than steel cable. So this thing here can easily hold like 900 kilos of weight, this thin piece of string. Now, since it worked so well on my homemade crossbows, I thought, can we make a crossbow string out of it? And we can, and I'll show you how. So this is a homemade but professional looking complete Dyneema string for the adder, and I'm going to show you how to make it. First you're going to need Dyneema. I use the Canny Rope brand. It's actually, I think, made in the Netherlands probably. And this is actually a 100-meter roll, and it costs about 90 euros. But you can also get this in just shorter pieces, like 10 meters and so on. And then of course it's a little bit more expensive. But it needs to be the pro stuff from Dyneema and not from some other polypropylene stuff and so on. Then you need some thin string, just this stuff here or anything, and a scissors. As you can see, I'm not using knots, but I'm using a technique called splicing, which is far more robust than a knotted string. Knots actually weaken your string very much. This is professionally spliced, and you need some splicing tools to get the desired effect. And these are the tools that you basically need. You need like a hollow splicing needle, and you need this little wire thing to pull it through. But if you don't want to spend the money, this was maybe 60 euros, you can actually make it at home much cheaper. So this is a splicing needle that I made from an old broken aluminum shaft for a pistol crossbow. And if you live in a place where it's still legal to own plastic straws, you can also use a plastic straw for the purpose. As you see, you just cut it off and cut it open a little bit, and then you're done. And the wire tool, I simply used some copper wire from an electric cable and made it myself, and it works just as good as the shop bought one. Now it is critical that you get the exact right length of your string if you make it at home, because otherwise it's useless for shooting. So I always start by just using the standard string and then a piece of wood and some nails, and I just then hammer in the nails so that the string is loose fitting, not too strong, just like this. So it is actually very loose fitting. That gives you the perfect length when you're finished with it. Just cut off the heads of the nail and round it a little bit to not cut the string when you put it on and off. So we start by manufacturing one of the loops, and first what you do is you measure about 20 centimeters, that's just about 8 inches, and that is where your loop will be. So like so that you have 20 centimeters, 8 inches dangling down. And then you take the splicing needle and actually you go down about 3 centimeters, a little more than an inch on the longer side, and you press it together so that it will actually open up a little bit, like so. Then you take the splicing needle, homemade or store-bought, and carefully, not really damaging any of the strings, you fumble it through. And then it automatically widens like this. And now you can put the rear end of the string just through here and pull. Okay. Alright. Yeah, that is about the length of the loop that you want. And now you go down a little bit, just like a few millimeters really, and repeat the whole thing from the other side. Now a lot of people also pull through the loop side first. I've tried it and I didn't really find a difference, but this is quicker, so I like using this method here. Okay, and then the same thing. You put the rope inside of the hollow needle, you push this through, and pull tight, like so. Right? And now you go through one last time. Same thing, just a short little distance. Doesn't really matter if it's a few millimeters more or less. Okay, you go through one last time. So, okay. Now we have the beginning of our splice thing. Just what to do with the end? Well, we put it inside of the rope. Put it down like so. And then you go a little further than the end of the short string, like here. Then you push in order to open up the woven piece. Then you take your professional tool and put it in. And now what you do is you just push it through. And then when you're almost at the top, you pop out like so. Okay, like this. See? And now you actually squeeze this apart a little bit and you put the end of the string through and you pull it all the way up into the eyelet here. So it's like this. And then you pull And you push the whole thing against it so it opens up again, and then carefully push it through. Like so. Until it comes out at the end, and then you take out your needle, pull a little bit, and then you stretch the whole thing out, and magically you have a perfectly spliced eyelet. So as you see, this won't come out at all. It's super solid, because as soon as you pull on the string, this thing tightens and it clamps in the piece of the string that is in there. So you need no glue, you need no knots, and you actually waste not 1 inch of this rope. You use every little bit there is. Okay, next we have to determine the length of this thing, and we put our rope on here, and then we go around the string here. So, and then we measure our 20 centimeters, 8 inches. We take our scissors, and then we cut. It's not easy to cut this string, but after a while it will give up. Okay. Now, in order to make sure that our rope stays at the exact same length when we do this entire splicing thing, we take a little bit of this thin string to stabilize it. I like to tie the constriction knot around it, but if you don't know how to tie it, or if you prefer other knots, you can do this. Just put it around here, tie it loosely, like so. Okay. Then what I do is I pull on one end, make it really tight, and tighten the string here, like so. Now this makes sure that the length is not going to change. And you also see that the string is now a little bit tougher on here, and this is normal because it will lengthen a little bit, about 1 millimeter on the first 20 shots. It will then get to the final length. So we start out making it a little shorter than the original string. It will also lose a little bit of the length due to the splicing. So when we're finished with it, it won't be possible anymore to put it on this nail here. Okay, so now we are taking this off here. And we do the same thing that we did on the one side with the other side. Voila! And now we take a sharp knife and cut off this piece of string. And now what I always do is I put this into the vise again, like so. And then I stretch it a little bit. Usually we're using something like this here. Just to make sure that everything is pulled nice and tight. Okay. And now you will see that the string is a little bit too short. See, it lacks about 4 millimeters in length, so I can't reach the nail. And that is normal because the Dyneema has a lengthening after under strain of maximum 1%, the SK78 type that I'm using. So this means that in the beginning our string will be a little bit shorter than the original one, but that will then after a few shots go away, because then the string will stabilize in length. Now if you want, you can now wax the middle part of the string a little bit. You don't have to do this because it's Dyneema, so it will hold for a long time even without any wax. But I think that it adds a little bit of speed if it's waxed, because a little bit less friction. Only the middle part, which is easily to find because it's a little bit thinner. See? Okay, here is the adder. Already removed the magazine and put on the help string that is part of the package, so that we can easily install the new string. For doing this, we just put this through the eyelet of the help string, and we put it then on the main part. This setback one is only for the help string. Then we do the same on the other side. Okay. And then we release this carefully and remove the head string. Okay. And now you see that in fact, because the string is a little bit shorter, you see that there is maybe a centimeter of a play here between the stoppers and the string. And this will stabilize as soon as we shoot a few times with it. Sorry, forgot to switch on the camera. But as you see, I've done now 6 shots with it and it's almost back to normal. So you see it almost touches the string stoppers. And now we'll do another few shots for you, and then you see that the length has stabilized and won't change any further. So we're starting out with the string still a little bit too short. One more. Okay, and you see that it's now almost touching it. After 20 shots it will, and then it will stay that way forever. Now people ask, can you also do this for compounds? Yes, sure. This is a siege, and as you see, I'm using a Dyneema string for the compound too. This works great. I also put one on this one here because actually the original string was so low quality that it broke on me after like a few shots only. So I replaced it with this here. And now it's holding and holding and holding. Dyneema! Can you also use it for full-size crossbows with the series draw weight? Sure you can. So I put it on the Steambow Onyx, which is a really big crossbow with 225 pounds of a draw force. And this of course has the air-powered cocking system. So let's do just that, let's cock it. I put the 4mm Dyneema type on here, not the 3mm, but I think the 3mm would have worked just fine. 4mm just gives you extra power. Okay. Whoa, look at how much power is now stored in this. Is this a problem for the Dyneema? Of course not. Let's fire it. Okay, I hold it a little bit higher so you can see. And a little bit sideways. And fire! Whoa! And as you see, the string is perfectly intact. No wear, no tear, no nothing. Great. Now can you also take the 4mm and put it on the pistol crossbows instead of the 3mm? Yes, and it does give you more shots. My experience is that you will get about 450 shots with the 3mm and about 700 with the 4mm type. But the 4mm type is a little bit slower because it's heavier. This means you lose a little bit of arrow speed, but you win, of course, lifetime of the string itself. Now, of course, also people say, now is it shooting slower than a regular string? No, it's not my experience. My experience is that typically the 3mm type gives you a little bit lighter string and therefore you win a little bit of power. I clocked this for the adder and I got 35 joule on the commercial string and 38 joule on the Dyneema string. So if you take the 3mm type, you actually gain a little bit of speed. Ain't that great? I just think I made a disruptive discovery. It could have been found out earlier, of course, because the Dyneema string has been around for some time, but I think just nobody ever tried it. Everybody was so convinced that this is the way how you have to make a crossbow string that nobody ever tried that kind of stuff. And now I think it's going to change the entire industry. And why? Because, well, it's the string that makes a crossbow unreliable. It really is. I mean, if it needs maintenance every 10 to 30 shots and replacements every 100 to 150 shots, that's not a reliable weapon. There you can't live with. If it breaks after 450 or 700 shots, who cares? I mean, who does that many shots in a single day? But I believe you need to be able to grab your repeating crossbow and go to the range or wherever you want to shoot it and then shoot the whole afternoon and go home with the thing fully intact. That is the way how a reliable weapon needs to work. And with the Dyneema string, I think we can do just that. I believe it's a major discovery. So, I hope you liked this, because that's it for today. Thanks and bye bye.